Right. Okay, scoot up. Please scoot up if you can. Got one more day of going through. I think we'll get through this stuff today. And then we'll just have a brief review Monday, and then you're good to go. Tuesday and Wednesday, we're testing. So one thing real quick before, just in case I forget to tell you this, Monday. So on the SBAC test, there is no time limit. It's probably not going to take you super long, but take your time. Absolutely take your time. As we're going through this today, you'll see there's lots of questions where you really have to read and interpret the questions. So definitely take your time. Okay, so how about something like this? So what are they asking us for here? They're saying if the point 10b is a solution to the equation represented by the graph below, what's the value of b? So what's the y coordinate at 10? So no big deal. All they're asking us is out here at 10, what's going to be the value of y, right? How are we going to get that? Well, you could just get the equation of the line, right, by finding the slope and solving for b, or actually you can see that b is 5, right? So just finding the slope, putting it in slope-intercept form and plugging in 10, that's fine. But you really don't even need to. We could just make slope triangles, couldn't we? Right? If we go from point to point, how much are we rising? 2. Careful, look, make sure you look at the scale. 4. So we're going up by 4, and how much are we running? 6. Yeah, we're going over by 2s, aren't we? And we're going to go 3 spaces, so 6 total. So then if we wanted to go up to this point, we're going to scoot over from 4, we're going to scoot over 6. We're going to run 6, and we're going to rise 4 again. And where do we end up? At the point 10 what? 12. So B is 12, right? No biggie. Okay, this one. This question, really, this one is, it looks a little different because it's a function. We haven't talked about exponential functions yet, but they're not a big deal. You're not going to see very much of them. And you don't even really need to know for this one. Really think about what this is asking. The graph represents the equation y equals 4 times 2 to the x. So it's an exponential function. How many ordered pairs of the form xy, meaning how many points, satisfy the equation when x is greater than -1 and less than 2? So how many points are there on the graph? In other words, that's how you could think about this. How many points sit on the graph between x equals -1 and x equals +2? You might think, well, just those 2, but that's not right. How many points actually are there on the graph of that function? Infinite, right? Any function is made up of a set of an infinite number of points that just follow that pattern, right? If we take a line, for example, and I take any 2 points on the line, doesn't matter how close together they are, how many points are there between those 2 points on the line? Infinite. It doesn't matter how close you think you're getting, there's still an infinite number of points in between them, right? It's a little strange, but that's the way it is. Okay, so how about this one? The graph of a system of linear equations is shown below, so I've got these 2 lines. How many solutions does the system have? Just by looking at that, you can tell. How many? 1, right? The point of intersection is the solution, right? It's only got 1. What if they ask you to, based on the graph of a linear system, to determine what is the solution? Well, you're just looking for the ordered pair of the point of intersection, right? So it'd be the coordinates, so it's 4, 0 in this case. What about this? So this time they're, and you got to read this one. It's an easy question, but it looks hard until you read it and think about it for a second. It's really not bad. So the graph of y equals p of x is shown. P is a quadratic function, okay? Select 1 or more intervals with consecutive integer endpoints. So you got to be able to think about that and interpret what they're asking there. Consecutive integer endpoints. What does consecutive mean?
Right after.
Yeah, sequential or next to each other, right? What are integers? So they're real numbers, but they're more specific. Integers, remember, what I always say is they're where the hash marks are on a number line, right? The dashes. So it's all the positive and negative whole numbers, right? So then we want to know what are the intervals between integers that would contain the solutions to this equation. So let's think about that. If 9 equals p of x, well then aren't we just plugging in a value of 9 for y? Right? Does that make sense? So if we're plugging in a value of 9 for y, we're just looking for the places on the graph where y is equal to 9, right? So if we go up here, there's 9, there's y equals 9. So would you agree that that's a place right there and that's a place right there where the function has a y value of 9? Okay, so then that value right there, when y is 9, if I just move on down, that's hitting the x-axis between -3 and -2. So that's going to be the interval between integers that contains that solution, right? Does that make sense? Same thing here. This one, if I move all the way down, it looks like that's at x equals 4.8 or something like that. It's somewhere between 4 and 5. So those would be the two intervals that I'd shade. See what I'm saying? It's really not difficult at all. You just got to be able to read the question and know what they're asking. Okay, how about this? The graphs of y equals f of x and y equals g of x are shown. Indicate whether each statement is true or false. All right, we can do that. So what's it asking is, it wants to know, is g of 0 less than f of 0? True or false? Okay, well, let's see. F is the line and g is the curve, right? Well, what's it mean when we say g of 0? What are we doing to g of x? Putting in 0, right? So we're putting in an x value of 0. So g of 0 means that's going to be the value of the function right there, right, when x is 0. F of 0 is going to be the value of the line, that function, when x is 0. So there's g of 0. There's f of 0. Is g of 0 less than f of 0? False. It's above it, right? So it's got to be greater than. So that's false. Let's just look at one more of these. Wants to know, it says, is x equals 3 the approximate solution to f of x equals g of x? So is that the x value where they intersect? Well, it looks like it, doesn't it? There's the intersection. It looks like it's at the point 3 something. We don't care what the y value is, right? They just want to know, is x equals 3 the solution to where they cross? And yeah, it is. It's where they cross at that x value. Make sense? Okay. What about this stuff? Okay, let's review this. This is something you may need to refresh your memories on a little bit. It's not hard though. So the graph is shown. A graph is shown here of a region, right? We want to know, how could we write an inequality that's going to represent that shaded region, right? So think about how this works now. Let's go back to when you last talked about this. So this is just going to be, there's going to be a boundary line, and then we're just going to choose the inequality sign that shades the right region adjacent to the boundary line. Is it going to be the part to the above it or below it, right? So first of all, we have to come up with the equation of the boundary line, right? And we'll just put it in slope-intercept form, right? So what's the y-intercept? What's b?
-4.
Looks like it's -4. Okay. So b is -4. What's the slope? How could we find the slope? How can we do that?
Go from 4.
Okay, so yeah, we could go from there up to there. How about? We're just going to make a slope triangle, aren't we? So from this point right here.
Can we get these to the kids in TA?
In my TA, sure.
Yeah,
Thanks. Okay, so then we're just going to do this, right? We're just going to make a little slope triangle. So we're going to go from there up and over. It looks like we're going to rise by 4 and run by 2, right? So then what's the slope going to equal? What's rise over run? Looks like it's +4 over 2, right? Because we always have to go from left to right. We're going to start to the left and move move to the right. So yeah, it's gonna equal 2, right? So the equation of the boundary line is y equals 2x minus 4, right? But we're not graphing the line, we're graphing the region, right? So then we have to ask the question, what goes here instead of an equals, right? Because that's the equation of the boundary line. Here's how you tell, it's really simple. If the part that's shaded is the part directly above the line, then it's going to be a greater than. Then that's like saying the y values that are shaded are greater than or above the line, right? If it's the part that's below the line, then it's going to be a less than. So what about this case here? If we take a random point on this boundary line, and I go straight up from the boundary line, am I in the shaded region? I'm not. If I go down, I am in the shaded region, right? So what should that symbol be then?
Less than.
Should be less than. Because the y values I'm shading are below the line 2x minus 4. See what I'm saying? That's a really easy way to do it, okay? So how about this though? Here's the other question. Do I or do I not include an equal to sign with that? I don't. How come?
It's dotted.
Okay, because it's a dashed line. It's not shaded. It's not solid, right? If it's a dashed line, it means it's just a boundary line, but it's not included in the shaded part. If it were a solid line, it means it's actually a part of the shaded region, and so it gets the equal sign too, right? Easy way to remember that is, it takes more ink to draw a solid line than a dashed line, and it takes more ink to draw a less than or equal to than just a plain old less than, right? Make sense? Okay? So that's our answer. Okay? There's one other thing you could do here that I'll just mention, and you may have done it this way in the past too. The other way we could answer what goes there is we could pick a test point. And you very easily might have done this in the past. Pick a test point that's not on the boundary line and see if that test point makes the equation true or false. If it makes the equation true, let's put all the phones away, please. If it makes the equation true, then that means it's part of the shaded region. If it doesn't make it true, then it's not part of the shaded region. It's on the wrong side of the line. So if we picked, for example, the test point 0, 0, see if it works. If I plug in 0 for x and 0 for y, I would get 0 is less than 0 minus 4. Is that true or false? Is 0 less than negative 4? No, it's false, which means that that point right there is not on the shaded side, so I would shade the other side. Either way works, right? Take your pick. Okay, so let's look at one more of those. How about one like this that's actually a system? It's two shaded regions combined, right? Remember, when we solve a system, we want to find the values of x and y that make both of the inequalities in this case true, right? So if you kind of think about what this is going to look like, I'm going to get a shaded half plane from the first one and another shaded region from the second one. And the solution to the system is going to be the part or the region that's double shaded, that's shaded by both, right? Okay, so let's talk about how we could do this one. How could we do, for example, that first inequality? How could I graph that? Ideas. This one looks a little different than the last one, but we could make it look the same, couldn't we? What can we do to that top one?
Subtract y.
We could subtract y. Yeah, we could. We could also just add 4x. Might be easier to add 4x. Then that's going to put it in the form y is greater than mx plus b, right? Everybody see that? If I add 4x to both sides, this one's just going to end up being y is greater than 4x plus 0, so y is greater than 4x, right? So is the boundary line going to be shaded, or is it going to be solid or dashed? It's going to be dashed, isn't it? Because it's not including an equals. And then let's graph it. So that boundary line is going to have a slope of what? 4, y-intercept of 0. So it's just gonna look like, so we'd start there, and we'd rise 4 and run 1, and then I could make a line, connect and extend that, right? And make it dashed, okay? Which part am I gonna shade? Well, because this is y is greater than, am I gonna shade above or below the boundary line? Above. I want the y values bigger than the line 4x, right? So we'd come down and we'd shade everything that's above that first line, right? So that's the solution to the first inequality. What about the next one? Okay, how am I gonna do this guy right here? What could I do with that? What do you think? Suggestions? I could subtract the x. Okay, so one strategy would be to subtract x from both sides. And then I'm going to get, that's going to give me minus 2y is greater than negative x plus 6, right? Now what?
Divide by -2.
Okay, divide by -2. And I'm going to divide each term separately by -2 maybe, right? Because I know I want to keep them separate, okay? So that's going to give me a y over there. Negative over negative is positive. Now, how am I going to say x over 2 in a way that's going to make it look like something times x, m times x? 1/2 x, right? So that's going to become a 1/2 x, and 6 over -2 is -3. Okay, but what's the inequality sign going to be? It's going to be less than. How come?
Divided by
Good, because I divided by a negative, right? When I divide both sides by a negative, I have to flip the sign, right? So we end up with y is less than 1/2 x minus 3, okay? So we can graph that. That's just going to be, see, we're going to start off at y equals 3, and then we'll rise 1 and run 2, right? So I'll connect and extend. So there's the boundary line, right? And then because I've got a y is less than, am I gonna shade above or below? What do you think? Below, yeah. I want the y values below this line, right? So we'll just shade down here. And where's the part then that's gonna be, the shading's gonna be overlapped? It's just gonna be in that little piece of pizza down there, right? Does that make sense? Okay. Okay, the other thing, there's another way to do this though I want to show you, because that's not hard to do, but there's a lot of algebra in there. Could we do it without doing that algebra? Yeah, you can. We could do this also. You might remember me talking about, it's been a while since we did this stuff, but we did do this in class. It's been quite a while ago. So one thing we could do, remember when we want to graph a line, really all we need are 2 points. If I can get 2 points, I can just connect and extend, right? So where is the, what's the value of x at the y-intercept always? 0, right? It's always 0. X equals 0 at the y-intercept, right? So we could, in that second, let's just do this for the second equation. We could just let x equal 0 to find the y-intercept, and if x is 0, that term right there just goes away. So this is the cover-up trick I showed you, right? You can cover up that term and solve for y. Okay, so Gage, what's going to be the value of y then if I were to solve this equation?
Wait, no, 3.
No, you're almost, but not 3. -3, right? Because 6 divided by -2 would be -3, right? So that's going to give us the y-intercept, -3. So we could go down, and we already had that point, right? There it is. There's my -3. Well, to find the x-intercept, we can do the same kind of thing. Y is equal to 0 at the x-intercept, right? So I could cover up that term, and then I just get x equals 6. Okay, so here's the other point right there. Of course, it's going to give me the same line, right? Now the question is, how do we know which side to shade? Well, if I didn't put it into this form, I've got 2 options. One of them is I could test a point. Let's test the point. How about let's test the point 0, 0, because that's not on, 0, 0 is not on that line, is it? It's not on this bottom line. So if we test 0, 0, what do we get? If I put 0 in for x and 0 in for y, I get 0 is greater than 6. True or false? False. So I'm going to shade not this side, I'm going to shade the other side, right? So that's one way I can know to shade down. The other way is, just imagine this. Now, if you were going to, you don't even have to do the algebra, but if I were going to isolate y right there, I'm going to get rid of the x, but to get y by itself, I'm going to have to divide by a negative, aren't I? What's that going to do to that inequality? It's going to make it less than, isn't it? So you can see that if you did the algebra, you don't even have to do it, but you can just anticipate that if you did, you're going to get y is less than some stuff. Don't even care what, right? Which means we would shade below. Okay? Make sense? Okay, I know that's a quick review, but I think it's enough. That'll get you going on those. Okay, what about this one? Once again, this is a really easy question if you just read the question carefully and think about it a little bit. It says we got the height of a rocket is h in meters. The time in seconds after launch is given by t, right? So here's h as a function of t, height as a function of time. Okay, what else does it tell us? It tells us that t is greater than or equal to 0 and less than or equal to 12. So that's the domain, isn't it? Because t is like x, that's the input variable, right? Here's the range, because the output is h. And it's telling us that the height, h, is greater than or equal to 0 and less than or equal to 180, right? Okay, so we have all that information. Now we're just supposed to choose all of the statements that are true. Okay, so Brendan, how am I going to know if this one is true? How could I check it?
Input 5 into the top.
Input 5, exactly. We're going to input 5 into h, aren't we? So if we input 5 into h, and you'll have a calculator, that's going to give you negative 125 plus 300 is positive 175. Your calculator would tell you it's 175, so it's true. Good. What about the next one? The height of the rocket is 0 meters after 12 seconds. Same deal, right? I'm just going to input 12 for h, and I'd get negative 720 plus 720 is 0. So it's going to, your calculator would tell you it's 0. Okay, so that one's also true. H of 0 equals 40. False. If I input 0, I'm going to get 0 plus 0 is 0, right? H of 0 should be 0, so that's false. And what about the last one? The last one looks like you got to do a lot of work. The rocket reaches a height of 360 feet. So it almost kind of looks like you got to plot this parabola and see where the maximum is, but you don't. You can see that it's false right away. How come?
It's greater than
It's greater than 180. The range is between 0 and 180. So the biggest possible value of h is 180, so that's false, right? Okay. How about this? There's some stuff on here that we haven't really talked about in detail yet, but we've had enough discussions earlier in the year where I gave you kind of some additional information when we talked about this stuff that, yeah, you can get this stuff. It's not a big deal. Remember, what this all comes back to when they're asking for the domain of a function, this all comes back to the two things you can't do for real numbers, right? There's two things you can't do. We can't divide by what number? 0. So that's one thing we can't do. We can't divide by 0 or the function blows up. It doesn't exist. And we can't do what else? For real numbers. Can't do what? Can't take
Square root of a negative.
square root of a negative, right? Because if we do, we get i's, and those are not real, right? So then let's look at each of these functions and just see if there's any places where, you know, we have to restrict, where the domain has to be restricted because we can't do that stuff. How about this first one? You just got to look at it and say, are there any square roots? There's no square roots, so we don't have to worry about ever taking a square root of a negative. But let's see. Tyler, are there any places where I might end up picking an x value that would cause me to divide by 0? Is there an x value that would make the bottom 0? 6, right? So 6 can't be part of the domain. We have to eliminate that one because the function would blow up there. It doesn't exist there. So that's going to be our domain for this one. X is not equal to 6. Okay? What about this one? So if we look at this one, we've got this square root function, right? We know that we can't take the square root of a negative number. So whatever's inside the square root function, which in this case is just a 6 minus x, can't be negative. So if it can't be negative, what could it be? Positive or 0, right? Does that make sense? So if it's non-negative, whatever is inside the radical has to be greater than or equal to 0, right? All we've got to do to find out the x values that work then for this function is solve for x. How do I do that? Subtract 6. So negative x is greater than or equal to negative 6. Now what? Divide by negative 1. So I get x and 6. What does that do to the inequality if I divide by negative? Flips it. So there's my domain. X is less than or equal to 6. How about that? Right? So that's the one that works. Right? How about this one? Well, that one's actually okay, isn't it? It's okay because there's no square roots that have x's under them, and there's no x on the bottom. So the bottom could never be 0. It's 6 all the time, isn't it? Right? So that one would be true for all real numbers. And then finally, this one down here, we'd have to do the same kind of thing we did in the second one. Right? We'd have to say, okay, x plus 6 has to be greater than or equal to 0. So what is x? What do I do? Subtract 6. So x is greater than or equal to negative 6. So that's going to be the domain for that one. Right? Not that bad. Okay? What about this then? For what values is the given function undefined? Where is it not okay? Where did it blow up? Well, wherever the bottom is 0 in this case, right? Well, when is the bottom 0? X squared minus 4 would be 0 when x squared equals 4, right? So if I solve that, what do I get? X equals plus or minus 2, isn't it? Plus or minus the square root of 4. Okay, that's what we got. All right. We can skip that. Okay, let's take a really quick look at these. These aren't a big deal, really simple. We've talked about all this stuff. So these kinds of questions, here it wants to know the equation of any line in the coordinate plane can be written in the form ax plus by equals c, right? So we've done that, standard form for a line. A, b, and c are real numbers. Choose all of the equations below that define y as a function of x. Oops. Okay, so we just have to remember what the definition of a function is. That could come up quite a bit, but it's really simple. Definition of a function is just any relation, right? Any equation or whatever we're dealing with, equations in this case, where for every x value there's what? One y value. Each x value has only one y value, right? No more than one. So what's that look like in terms of a graphical test? When we look at the graph of a function, like let's do number 6 real quick first. Just based on the graphs of these, which of those 3 is a function? B is, isn't it? Because it passes what test? Vertical line test. These other 2 fail the vertical line test, right? So that's graphically what that means. For every x value, there can only be one y value, so points can't line up vertically, right? So there's a couple ways you can think about these. We could think about them in terms of the definition of a function, or we could think about them in terms of what their graphs look like. So how about this first one? 0x, well the x just goes away. We get the equation 3y equals 12, so that's the equation y equals 4. Now what kind of line is that? Y equals 4.
Horizontal.
Yeah, that's just a horizontal line, isn't it? That's just a line that goes through 4, right? And it's horizontal. So if it's a horizontal line, does it pass the vertical line test? Sure, right? So it's a function, right? The other way you can think about it is if y is always equal to 4, then each x value only has one y value that goes with it, right? How about this one? Well, we could graph the line, but we don't need to. If I graph that, aren't I going to get something like y equals mx plus b? It's going to be a line, isn't it? And so it's going to pass the vertical line test. How about this one? It's got both x's and y's, so it also is going to be y equals mx plus b, so it's fine. What about the bottom one? Bottom one, if I solve that, I get x equals negative 10/3. Now what does that look like? That's a straight line. In what direction does it go? Vertical. So if it's a vertical line, does it pass the vertical line test? No. It doesn't, does it? So that's the one that's not a function. Vertical lines aren't functions. Okay? All right, same kind of thing down here. If we look at all three of these patterns where we're picking ordered pairs from these functions, we want to know in which case could the function, or could the table represent a function, in which case does it definitely not. Well, this first one, that could be a function because of all the ordered pairs that they showed us. Notice that each x value only maps to one y value. Yeah, it's the same y value, but who cares, right? Evidently, it's just a horizontal line, right? Does that make sense? Okay, bottom one's fine. Each x value only maps to one y value, but the middle one, we got problems. Middle one, notice that the x value 7 maps to a y value of 4, and it also produces a y value of 1. So that's no good, right? Those points are going to line up vertically. It violates, it's not a function because each x value can only give us one y value, right? Okay? Interpreting graphs. There's going to be a lot of questions that just ask you to interpret graphs. But they're not hard. If you just take your time, they're going to be really easy. Like look at this one here. It tells us the number of music downloads as a function of time. So number of downloads versus what day it is, right? How many days. So we just got to pick which of these statements are true and which are false. The greatest amount of downloads was 180. True or false? How come? Yeah, the line goes higher than 180, doesn't it? Right? So that one's false. Around day 42 was when the least amount of music was downloaded. That seems about right, doesn't it? There's 40, so right about there's the minimum. Seems good. There are 3 intervals where music downloads decreased. False. How many do you see? I only see 2. There and there, right? And then finally, the amount of downloads increased between days 30 and 50. So there's day 30, there's day 50. It looks like between those two, the number actually went down, right? So it decreased. What about this? Same kind of thing, only this time they're giving it to us as a table instead of a graph, but same type of information. So we're looking at the height of a golf ball as a function of its horizontal distance. So somebody teed off and hit this golf ball up in the air, and it, right? What did it do? So the horizontal distance increased the whole time, right? That makes sense. It would. What did the vertical distance do? What did the height do? It looks like it increased and then it decreased, right? Everybody see that? Okay, so then what are these questions? How do they make sense? The ball's height increased the entire time. False. The height got bigger and then it got smaller, right? The ball reached the ground again at 300 yards from its starting point. Yeah, it did. At 300 yards, the height was 0, right? Okay? The height of the ball decreased from a distance of 120 to 185 yards from the starting point. So 120, it's at 18. And at 185, it's also at 18. So did it decrease? Stayed the same, right? What it's done is it's gone up, and there it is at 120, and then it goes back down to that same height at 185. So it's the same height. That's false. Does this make sense that if this is a graph of Joey's riding his bike and it's his distance from home, the star is where he's furthest from home, and the diamond is when he gets back home? His distance is 0, right? Okay, what about this one? Let's take a quick second on this one. Not hard, but there's a couple little concepts I'll remind you about. This gets pretty easy. So a model rocket is on the ground. It launches into the air at s equals 0. Assume the height of the rocket can be modeled by a quadratic function. What does the graph of a quadratic function always look like? What do we call that? Parabola, right? It's always a U-shaped parabola, right? The parabola, what do you know about parabolas? Do they have symmetry? They do, right? They do. They always have folding symmetry about the axis in the middle. If you draw a vertical line through the vertex, each part looks like a mirror image of the other, right? So we know we have that kind of symmetry. Now look what they tell us here. it reaches a maximum height of 100 feet. So we know that the vertex is going to have a y value of 100, isn't it? Because that's going to be the maximum. And it lands 8 seconds after reaching its maximum height. So if it took 8 seconds for the rocket to go from its highest point to the ground, right? How long did it take to go from the ground up to its highest point? It's got to be 8, doesn't it? Because it's symmetrical. It's a parabola, right? So we know then that if it took 8 seconds from when it left to get to its peak, the coordinates of the peak, the maximum, must be at 8, 100. So they're right there, right? And that means that one point is going to be down here at the very beginning, right? And 1 is going to be where it hits the ground again, which has got to be 8 seconds later, so it's at 16, right? See how that works? So it seems like it'd be really hard, but it's not that big a deal. Okay, this one, simple. You've seen stuff like this before. All they're saying here is, can you graph a function that's going to have different pieces with different slopes? That's it. So it's a piecewise function. So what if we want to graph a function that represents the cost of gravel, right? So for the first 8 cubic feet, it's $2.50 per cubic foot. So it's starting with the amount of gravel starts at 0, right? And what does that $2.50 represent then for that line? It's dollars per cubic foot. What does that sound like? That sounds like a rate, doesn't it? Something per something. So that's the slope, right? So 250 is the slope. So I go up. Every time I go up 250, I'm going to go over 1. So if I go up 5, I'd go over 2, right? If I go up 12, I'd go over 3. Oh, hold on. Sorry, if I go up 10, I'd go over 4. That's a better one, right? Does that make sense? Okay. So there's the slope for the first part right here. We start at the origin, and we're just going to go up to where? To right, whoops, went too far. I'm going to go up to right there, where the slope is 2.5, right? Then it says, an amount of gravel greater than 8 cubic feet and less than 16 cubic feet, it gets a little cheaper if you buy more. Then it's only $2, right? So what's going to happen there? Well, then from this point right here, when I get to 8 cubic feet, now the slope is going to be a little less. Now it's just 2, right? And then if you pick an amount more than 16, then the slope just becomes 1, right? And I'm just connecting those segments. Okay, not a big deal. You can do that. Just take your time. How about this? Choose the graph that correctly represents the amount of money Y that Tessa earns babysitting for X hours at $5 per hour. So that's the rate, isn't it? Right? So we just know that for every hour, the amount of money she earns is going to increase by 5. So it's got to have a slope of 5. Well, both C and D have a slope of 5. Why does C make sense, but D really doesn't for this situation? She's not losing any. Yeah, it's pretty hard to babysit for a negative number of hours, isn't it? I'm not sure what that would look like, but that one doesn't make sense, right? You start with 0 hours and you get more from there, right? Okay, we can skip that. So what about this? And this is probably about, we'll just get through maybe a couple more and call her good for today. Pick up the rest on Monday. There's not much left to do. We only have to go up through a few more pages, like 5 more of these things, and we're done. So what about this? They want to know what's the average rate of change for the height of the tide measured in feet per hour between hour 4 and hour 8. So at hour 4, we're right there, and at hour 8, we're right there. So if we want to know the average rate of change, that just means the slope connecting those points. That's what average rate of change is. It's just the slope of the line connecting, right? That's an important thing to remember. So if we're going from here over to here, let's just figure out what the rise and the run are, and then that's going to give us the average rate of change of the slope. So what's the run from 4 to 8? 4. Okay, what about the rise? Well, you have to make an estimate here, and you have to read, you got to read the the side of this pretty carefully. So it's going by twos, isn't it? Right? So this one looks like it's just a little bit less, that 9 would be halfway between. This is just a little bit less than that. So I'm gonna say, you might say something different, but I'm gonna say it's about 8.9. We'd both be pretty close though, right? This one right here is just a little bit less than 10, because that's where 10 would be. It's maybe a little bit further from 10 than that was from 9 though. So I'm gonna call that 9.8, okay? So then our run is gonna be 0.9, right? 9.8 minus 8.9 is 0.9. So the slope would just be rise over run, which is gonna be something like 0.24 if you put it in your calculator. How do you know if you got it right? Well, when they were grading this, anything between 0.2 and 0.3 would have worked, so that would have been fine. You might have gotten a slightly different answer, but it's definitely gonna be in that range, right?
C.
Okay, we good?
C.
All right.